All right, so our objective for today is I can find the key features of radical functions. And radical functions would be anything with the square root or cube root function. So we might have square root of x functions, and we'll see cube root functions, okay? We'll see square root and cube root. So the ones that don't have the 3 are called square roots. And then the 3's would be called the cube roots. We're not going to have the actual equations today. We're just going to have the graphs. And then we'll be looking at the graphs to determine key features like the domain, the range, and then just increasing and decreasing. So for prior knowledge, we had a rational function here. So remember, rationals is when we had 2 pieces of the curve, and then we have the asymptotes. We have the dashed lines for the asymptotes. And then we need to determine the domain and range. So for the domain are the x values. And then I'll be using pink for the range. Range are the y values, okay? So if you remember looking at the graph, the domain and the range are being cut by one of the 2 asymptotes. So if you guys notice on the domain right here, what's cutting the domain is this vertical asymptote here, okay? So the vertical asymptote, I'm going to highlight it in blue just because I know that's what's cutting my domain in half. This is the vertical asymptote. All right, so this is cutting through this value right here. That's a 3. Is that an x or a y value of 3? This right here. Is this an x or y value of 3? This is an x value, right? So this is a x equals 3 is my equation to the vertical asymptote. So my domain is being cut at the asymptote here. I know that all the x values are less than 3, or I have all the x values greater than 3, okay? So we're going to write it as x less than 3 or x greater than 3. That's how we did it last semester for inequality. And then interval, we start from the left going towards the right. We have a negative infinity to 3 union 3 to positive infinity. All right, then my range are the y values. So the y values are being cut by the horizontal asymptote. So I'm going to take my highlighter and I'm going to highlight the horizontal in a pink because that's what's cutting the range. This is the horizontal asymptote, and it's cutting through this value right here of 2. So is that 2 value an x or a y? That's a y. So I got a y equals 2. Okay, so I have all of the y values down here that are less than 2, all of the y values that are greater than 2. Okay, so I have y less than 2 or y can be greater than 2. And then interval notation starting from the bottom. This is a negative infinity. Oops, sorry. Here, negative infinity to 2. And then from 2 to positive infinity. All right, and then for the increasing and decreasing, we had to look from left to right. So if I look at the left side going towards the right, am I increasing or decreasing? Decreasing. Starting at the left, going to the right, I'm going downwards. So because we're going downwards, that is a decreasing function. Okay. So this is what we did last semester with rational functions. We had the two curves and the asymptotes. Today, we're going to be learning about square root functions and cube root functions and what they look like, okay? So you can add yourself a note somewhere on your notes or something. I'm going to add just a blank. This is not part of your, like, it's not in your notes anywhere. But we're going to be looking at square root functions. So the square root functions, you can add this on like your front cover if you want somewhere. You don't have to, but you can if you want to. So the square root functions, our equations will have like square roots of x. And because we're taking the square root, remember we can't take square root of a negative. Like I can't take the square root of a -4 because it'll be imaginary. And so because of that, we have a restricted domain. So then our graph is going to have an endpoint. I'm saying I cannot go past that endpoint. And then I'm going to have an arrow pointing somewhere else. That's how the graphs are going to look like. It's going to have an endpoint and then it's going to point in another direction. Okay? Those are the square root functions. Again, that's because you cannot take a square root of a negative. Now the cube root functions. The cube root functions have no restricted domain. They'll have like a cube root of x. I can have a cube root of a positive and I can have a cube root of a negative. So there's no restricted domain. Which means I'm not going to have any endpoints anywhere. I'm going to have arrows on both sides. And it'll look kind of like a very curved S, like a very slanted S, I should say. It's going to look something like this. It's going to be a very slanted S. That's what the cube root functions are going to look like, okay? And they are going to have arrows on both sides. Okay? All right, so with that now, let's look at our first example. So if we look at our first example here, looking at the graph, the directions say to find the key features using the graph of the radical function. It doesn't tell you if it's square root or cube root, so you have to determine that in the first part. Is it a square root or is it a cube root? Well, I noticed that there is an endpoint here. This is an endpoint. So because I have an endpoint, that means, again, we have a restricted domain, which tells me then it's going to be a square root function. Square root function. Okay? Again, that's because the endpoint, it tells me it's a square root because I have a restricted domain. All right. Now for the next parts, the domain and the range. This is where I'm going to be using highlighters here. So for the domain, I'll be using blue. And then for the range, I'll be using pink. So if you remember, domain is domain the x or the y values. X values, which means then the range is the y values, right? So I'm going to take my endpoint and I need to figure out what x values correspond to this curve right here, okay? So if I take my endpoint and if I drag it to the x-axis, I'm going to put my dot right here. So I'm going to drag my endpoint to the x-axis. So I'm going to grab my highlighter and see. Then I want to check, is it curving to the left or is it curving to the right? Like the curve part is going to the right. So I'm going to highlight on the right side of the graphic. Okay. Again, I check drag the end point to the x-axis, and then check, is it curving to the left or curving to the right? It went to the right, so I'm highlighting the right side of the x-axis. Then I need to figure out the value. So that value right there for my endpoint is, what a value is this here? Can you guys tell what value that is? It's a 4. Good. And then it goes on forever to the right, which is which infinity? Positive or negative? Positive infinity. Okay. So for inequality notation, that's what the less than or greater than. Are these x values right here? This is 5, 10, 15, 20, 25, 30, 100, whatever. Are all these values greater than 4 or less than 4? Greater than 4, right? So it's all the x values greater than, but also equal to, because it's a closed circle, x greater than or equal to 4. Okay. Interval notation is when I use the brackets and the parentheses. So I look at the beginning of the interval to the end of the interval from left to right. So this is a 4 to infinity, and then a close to circle, it means I put a bracket, and the infinity, I put a parenthesis. Okay, so I put a bracket starting at 4, and I go over to infinity, and then infinities, we always put a parenthesis. Okay, for the range now, I'm going to do the same thing, except I'm now moving it to the y-axis, because it's the y values, okay? So take this endpoint here and drag it to the y-axis. So I'm going to put a dot right here at the 5. And I'm going to take my highlighter and then determine, is it curving to the top or to the bottom? Going up or down? Is going upwards, so I'm going to highlight the top of the y-axis. Okay, so what values is that? That is going from 5 and is going up forever to which infinity? Positive or negative? Positive, right? Okay, so inequality notation again is less than or greater than. So this is all the y values. Are these greater than 5 or less than 5? Greater than 5. But also including the 5. So greater than or equal to 5 because it has a closed circle. And then interval notation, we start from bottom to top. So bottom of the interval is 5 to the top goes to infinity. So bracket 5, infinity, and infinities always have a parenthesis. Okay, then for my end behavior, remember that's the far left and the far right of the graph. This one, it kind of gets cut off right there, which implies there's an arrow at the end over there. So on this side, is that the left or right side of the graph? Right side. And curving up or curving down? Upwards. So if you remember when we did this before, we had the, I'm going to draw it right here. You guys can draw it on your front cover again if you forgot about this, but we had our x and y axis. The right side goes forever to positive infinity. The left side goes forever to negative infinity. It goes up forever to positive infinity, and then down forever to negative infinity. Okay? So if I look again at my end behavior, that's the right side going to infinity. So the right side is which infinity? Positive or negative? Positive. And it goes up. So it's up, positive or negative? Up is positive. So when I write my end behavior, I am going to say as x approaches the right, as x approaches the right side is a positive infinity. G of x approaches upwards is also positive infinity. And then on the other side, notice I have an endpoint. So endpoint, we don't talk about it for end behavior. So the endpoint, we just say like NA, it's an endpoint. I don't have an end behavior for the other one because it's an endpoint. All right, then looking at increasing or decreasing, remember that's checking from left to right. So from left to right, are we increasing or decreasing? So starting here at the left side, going to the right, am I going up or down? Upwards, so that means it's increasing. And it's always increasing from left to right. Okay? All right, so let's go ahead and look at the next example. You don't have to copy anything down. It's already there for you. So let's look again one more time. Looking at the curve, it has an end point. So again, because it has an end point, is that a square root or a cube root? Square root, because it has a restricted domain. All right, domain and range. This is where we're going to get our highlighters. So domain, I'm going to do blue. You can pick a color. It doesn't matter. You don't have to use blue. Just pick a color. And then range is going to be the y values. So again, you're going to take your endpoint. For the domain, you're going to drag it to the x-axis. Because the curve is below, you're going to move it to the top of the x-axis, okay? So this right here, move it to the x-axis, which is here on this value. And then is the curve going to the left side or to the right side? Right side. So I'm going to highlight the right side of the curve. Great. And what x value is this one here this time? -2. It's on the left side of the 0, so that's a -2. And it goes on forever to the right to positive infinity. All right, so are those the x values greater than -2 or less than -2? Greater than or equal to -2, because it's going to the right. All those numbers are bigger than -2. And then interval will go from left to right. So -2 to infinity. So bracket -2 to infinity, parentheses. All right, then for the range are the y values. So I'm going to take my endpoint, drag it to the y-axis this time. So drag it to the y-axis, and I'm going to put my endpoint right there. And then check, is it curving upwards or curving downwards? Downwards. So downwards, you highlight below the value. Okay? And what is that y value there? This one this time, it's 1 below the 0, so it's actually a -1. And it goes forever downwards to which infinity? Negative infinity. All right, so are those the y values bigger than -1 or smaller than -1? Smaller. So it's a less than or equal to -1. And then interval, we go from bottom to top. Even though it has a dot and then an arrow, you don't follow the arrow. You always go from bottom to top, okay? So the bottom of the interval to the top of the interval, negative infinity to -1. So parenthesis, negative infinity to -1, bracket. And I know students always make the mistake because they see the arrow, they're thinking it starts here and it goes this way. Don't follow the arrow, it's from bottom to top, okay? There's always left to right, bottom to top. It's the smallest to biggest value. All right, then our end behavior, we're looking at the arrows. So this arrow over here, is that the left side or the right side of the graph? Right side, and curving upwards or downwards? Down. Good. And which infinities is that? As x approaches the right is which infinity? Positive. G of x approaches downwards is which infinity? Negative. Thank you, Simran. And then for the other one, I have an endpoint, so I don't need to even worry about this one. It has an endpoint, so there's no end behavior for it. All right, then always increasing or decreasing. Again, you start from left to right. So farthest left, going towards the right. Am I increasing or decreasing? Decreasing. Good. All right, so next example, you guys are trying this one. And then I'll show you guys the solution after you guys practice it. All right, so in this one, it says find the key features using the graph of the radical function. Again, but notice this time there's no endpoint. On both sides, it's implied to be an arrow. There isn't really an arrow there, but the graph is being cut there, but it keeps going forever. So there's 2 arrows on both sides. No endpoint, so this one has no restricted domain. Because there's no endpoint, it's all real values, so that means it's going to be a cube root function. It's a cube root function because it's no restricted domain, all real values. So the domain are the x's. Again, I don't have any endpoints, so I'm actually highlighting the whole x-axis here. And I'm going from negative infinity to positive infinity. It's all real values, no restricted domain. So then when I write the domain in, I'm going to say going from negative infinity less than x less than positive infinity. That means it's all of the x values between negative infinity and positive infinity. That's all real values. And then in interval notation, I start from the left to the right. So from negative infinity to positive infinity. And those are both parentheses because they're both infinities. And those are the x values for the domain. Then I have the range values. So the range values are the y values. Again, I have no restriction at all. I have no endpoints. So I'm going to highlight the whole y-axis. And that also goes from negative infinity to positive infinity. Okay, it's basically the same as the domain, except now I'm talking about the y's. So when I write the range in inequality, instead of putting an x, I'm going to put a y. So negative infinity less than y less than positive infinity. And then parenthesis, negative infinity to positive infinity. Close the parenthesis. All right, then for end behavior, this time I do have two arrows, okay? I do have two arrows, so I have to talk about both sides. This one over here is at the top, is that the left or the right side? Right side, curving up or down? Upwards. So let's start with that one. We're going to say as x approaches the right side. So as x approaches the right side is which infinity? Positive. Comma, g of x approaches upwards, so up is positive infinity. All right, and then on this side over here, is that the left or right side? Left going down. So left down, I say as x approaches the left side. So left is which infinity? Negative. Comma, g of x approaches downwards is negative. And then is this always increasing or always decreasing? From left to right? Left to right is going up, so it's always increasing. And I'm going to add a note here for you guys. The domain and range is always the same for any cube root function. Okay, so domain and range is always the same for any cube root function. Okay, it's always going to be from negative infinity to positive infinity, both for the domain and for the range for any cube root, because there is no restriction. The only thing that's going to change really is the end behaviors and the increasing decreasing part. Okay. All right, and then for sake of time, I think we're going to stop there. We have like 4 minutes left, but I want you guys to help me clean up and sanitize the desk down. So we're going to stop there for today.